Hi, we're at the farmhouse again, and Sam seems to have some problem. What is bothering Sam? Aha! Sam has to keep a record of the number of eggs collected each day for 30 days. So, let's see how Sam is going to do this. Good! Sam has already made a list. Observe that Sam has used ordinal numbers to mark the days. First for 1, second for 2, third for 3, and so on, till 10 for 10. But Sam, you need to make a list of 30 days. Uh-oh! Sam doesn't know ordinal numbers for numbers greater than 10. Let's help him complete his list. Let's write the ordinal numbers for the next 10 numbers, that is, from number 11 to number 20. For numbers from 11 to 19, ordinal numbers are formed by adding the letters th after the number names. So, the ordinal number for 11 is written as 11 followed by th and read as 11. The ordinal number for 12 is also formed by adding the letters th. However, it is spelled as twelfth and read as 12. For the remaining numbers till 19, the ordinal numbers are formed by adding the letters th after the number name. So the ordinal numbers for 13, 14, 15 and 16 are 13th, 14th, 15th and 16th. Similarly, the ordinal numbers for 17, 18 and 19 are 17th, 18th and 19th. However, the ordinal number for 20 is a little different. It is formed by replacing the letter y at the end of the letters I, E, T, A. The ordinal number for 20 is read as 20th. Before we move on, observe the ordinal number for numbers from 11 to 20 once again. Now, let's write ordinal numbers for the next 10 numbers, that is, from number 21 to number 30. Let's consider the number 21. Number 21 is equal to 20 plus 1. The ordinal number for 21 is made of the number name for the tens followed by the ordinal number of ones in it. 21 has two tens, so the number name for the tens is 20. Also, 21 has one ones and the ordinal number for 1 is first. So, the number name for 21 is 21st. Similarly, we can form ordinal numbers for all two-digit numbers greater than 20 that do not have 0 in their ones place. So the ordinal numbers for 21, 22, 23, 24 and 25 are 21st, 22nd, 23rd, 24th and 25th. Similarly, the ordinal numbers for 26, 27, 28 and 29 are 26th, 27th, 28th and 29th. The ordinal number for 30 is similar to the ordinal number for 20. It is formed by replacing the letter y at the end by the letters I, E, T, A. So the ordinal number for 30 is read as 30th. Similarly, ordinal numbers for all two-digit numbers greater than 30 and having 0 at their ones place can be formed by replacing the letter y with the letters I, E, T, A. Now, Sam's list with ordinal numbers till 30 is complete. Let's observe the ordinal numbers of some more numbers. Can you guess their ordinal numbers? The ordinal number for 36 is 36th. The ordinal number for 57 is 57th. The ordinal number for 89 is 89th. It's time for more practice.
Hi there! Sella is playing with a string of beads. Hey Sela, how many beads are there in that string? There are 27 beads in the string. Can you tell which number we can count up to using 27 beads? Did you say 27 like Sela did? Wrong. Using 27 beads, we can count numbers from 0 to 999. We can do this by making an abacus. An abacus is an instrument used to quickly count, add and subtract numbers. Let us make a simple abacus. To make a simple abacus to show numbers up to 999, we need a block of plasticine, 3 pieces of wire and Sela's string of 27 beads. Let us push the wires into the block of plasticine so that they stand upright as shown. We mark the wire on the extreme right-hand side as ones. Next, we mark the wire to the left of the ones as tens and the wire onto the left of the tens as hundreds. Our abacus is ready. The 3 wires on our abacus represent the place values for ones, tens and hundreds. When there are no beads on the wires, the abacus represents the number 0. Each bead at the ones place represents 1 unit. So, using 1 to 9 beads at the ones place, we can represent the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9. Each bead at the tens place represents 110. So, using 1 to 9 beads at the tens place, we can represent the numbers 10, 20, 30, 40, 50, 60, 70, 80 and 90. Similarly, each bead at the hundreds place represents 100. Using 1 to 9 beads at the hundreds place, we can represent numbers 100, 200, 300, 400, 500, 600, 700, 800 and 900. Now, give us any number from 0 to 999, Sela, and we will show it on the abacus. Sela has given us the number 260. 260 has 2 at the hundreds place, 6 at the tens place and 0 at the ones place. So we can show number 260 by putting no beads at the ones place, 6 beads at the tens place and 2 beads at the hundreds place. This time, Sela has given us the number 508. 508 has 5 at the hundreds place, 0 at the tens place and 8 at the ones place. So, we can show the number 508 by putting 8 beads at the ones place, no beads at the tens place and 5 beads at the hundreds place. Now Sela has given us the number 345. 345 has 3 at the hundreds place, 4 at the tens place, and 5 at the ones place. Does the abacus show the number 345 correctly? No, it doesn't. The abacus here shows the number 354 and not 345. Now the abacus shows the number 345 correctly. Now look at this abacus carefully. Which number does it show? Here shows 9 beads, each at the ones, tens and hundreds places. So, it shows the number 999. So, Sela, do you see how magical your string of 27 beads is? It can really help us count numbers up to 999. If you have 27 beads, you too can make your own abacus and show different numbers on it.